This time, I will be sending a video on the theme of unexplained cosmic ray bursts that strike the Earth every 1,000 years. A research team from Nagoya University in Japan discovered an increase in the ratio of radioactive substances such as carbon-14 in the rings of Yakushima cedar trees believed to have formed between AD 774 and 775, and announced the research results in 2012. Trees grow by forming concentric layers of cells and gradually becoming thicker. Cell growth rates can vary seasonally, and in some cases, growth can occur with variations in color intensity over a one-year period, which is referred to as a tree ring. Counting tree rings allows us to understand in which year a certain layer was formed. Furthermore, the composition of substances contained in a particular layer reflects information such as climate change that occurred in the year the layer was formed. Carbon-14, which is a carbon isotope containing 8 neutrons in its nucleus, is extremely rare in nature compared to other carbon isotopes with fewer neutrons in their nuclei. This carbon-14 is formed during a chain reaction process that occurs when high-energy particles from space, called cosmic rays, collide with the Earth's atmosphere. In other words, if an increase in the ratio of carbon-14 is observed in a certain layer of a tree ring, it can be understood that many cosmic rays arrived during the year the layer was formed. Based on this, the research team at Nagoya University discovered an increase in the ratio of radioactive substances, including carbon-14, in the rings of Yakushima cedar trees believed to have formed between AD 774 and 775. Furthermore, similar phenomena have been confirmed outside of Japan, making it highly likely that a large amount of cosmic rays struck the Earth between AD 774 and 775. In fact, it has been revealed that books written in England, Germany, China Tang Dynasty, and Japan at that time contain descriptions that suggest large-scale celestial phenomena, which also support the increase in cosmic rays at that time. This sudden increase in cosmic rays is called the Miyake event, named after its discoverer, Fusao Miyake. Subsequent research has confirmed increases in cosmic rays in AD 993, 660 BC, 5259 BC, 5410 BC, and 7176 BC, indicating the possibility of such phenomena occurring roughly every 1,000 years. What is the cause of the sudden increase in cosmic rays known as the Miyake event? There is a theory that high-energy phenomena such as supernova explosions and gamma-ray bursts that occur at the end of the life of massive stars are the origin of cosmic rays, based on the sharp increase in carbon-14 in tree rings formed during a specific age. However, these events are extremely rare and have a very low probability of occurring at close enough distances to pour large amounts of radiation onto the Earth, and do not match the research results that show they occur many times in a cycle of about 1,000 years. Therefore, they are not currently considered plausible. Furthermore, the fact that there was no increase in carbon-14 concentration even around the supernova explosion SN 1006 in the year 1006, which is considered to be the most visible astronomical event recorded, also lowers the probability that supernovae and gamma-ray bursts are the cause of the increase in cosmic rays. At present, the most likely cause of the Miyake event is solar flares, explosive events that occur on the surface of the Sun. However, even around the 1859 solar flare called the Carrington event, which is considered the largest event in recorded history, no increase in radioactive substances such as carbon-14 has been found. To explain the increase in carbon-14 caused by the Miyake event with solar flares, it is said that it would have required a solar flare of an order of magnitude larger than the Carrington event, which was already several tens of times larger. If solar flares were indeed the cause, there is concern that superflares of such a large scale, known as superflares, could occur at a relatively short period of once every 1,000 years. It has also been suggested that some past Miyake events may have continued for several years. In that case, rather than a single superflare that usually lasts for several days, it may have been a powerful solar flare that continued for years. At any rate, the exact cause of the Miyake event is still unknown. When a solar flare occurs, various things are emitted into space, such as high-energy electromagnetic waves such as X-rays and gamma rays, high-energy particles radiation, and large amounts of plasma gas. First, high-energy electromagnetic waves such as X-rays and gamma rays emitted by solar flares travel at the speed of light and reach the Earth in just 8 minutes. When it reaches Earth, there is an increased risk of radio communication interference. High-energy particles radiation take about 30 minutes to 2 days to arrive on Earth. Because it is radiation, there is concern about radiation exposure to astronauts staying in the space station or airplane passengers as a risk. When a solar flare occurs, plasma gas with an electric charge that makes up the corona that hits the sun's atmosphere is released massively into space. This is called coronal mass ejection (CME). CME generally takes about 2 to 3 days to reach Earth, but if another CME occurred beforehand, the subsequent CME may arrive on Earth within a day because the material in its path to Earth is cleared by the previous CME. When plasma particles flow along Earth's magnetic field into the polar regions and collide with the substances that make up Earth's atmosphere, they emit light. This is the true nature of auroras. Although it is just beautiful in itself, if the magnetic field is disturbed, a large current flows through the power lines on the surface of the Earth, causing the power generation mechanism to be destroyed and causing a large-scale power outage. Japan's Ministry of Internal Affairs and Communications has estimated the damage that Japan would incur from a solar flare of a scale that occurs once every 100 years. In this estimate, it is assumed that explosions of a magnitude X10 class or higher of solar activity that occur once in one cycle occur intermittently for 1 week, and furthermore, giant flares that occur once every 100 years or less frequently, such as the Carrington event of 1859, are also assumed to occur. The damage in Japan would include the intermittent difficulty of radio communication during the daytime for 2 weeks. This would make it difficult to use radio communication equipment such as mobile phones, and is expected to cause significant confusion in transportation, such as trains and airplanes. Furthermore, it is expected that GPS communication will be intermittently difficult for 2 weeks. Also, artificial satellites orbiting the Earth would be significantly affected. Firstly, the solar cells mounted on the artificial satellites deteriorate, causing a significant reduction in the lifespan of the artificial satellites. Additionally, due to solar flares, the entire atmosphere of the Earth is heated and expands, causing an increase in air resistance on artificial satellites orbiting the Earth in orbits close to the surface, leading to changes in their orbit. As a result, there is a risk of collision with other satellites or space debris, and even the loss of the artificial satellite itself by falling to Earth. However, for the assumption in this case of a flare of the scale of once every 100 years, it is uncertain whether power outages will occur in Japan, which has advanced disaster prevention measures. The examples of expected damage listed above are just a few, but damage is said to be greater in cities with advanced communication technologies, with Tokyo suffering the world's largest economic loss. The concrete amount of loss is said to exceed $2 billion in Tokyo alone. If a superflare on a scale surpassing even this assumption, such as the Miyake event, were to occur, the damage would be even more unimaginable. What is frightening about this solar flare is that the more civilization develops, the greater the damage. If we do not take countermeasures as soon as possible, significant damage is sure to occur somewhere in the near future. Solar activity has a periodicity, with a cycle of approximately 11 years. If this cycle continues as predicted, the next maximum period is expected to occur around 2025, increasing the likelihood of powerful solar flares occurring at that time. It seems important for us to correctly recognize the characteristics and dangers of this phenomenon so that we can take appropriate action when this solar flare occurs.